Welcome back to Exploring Our Solar System. This is the last ever episode, and another thing is that this will be my final non-edited video on this channel. So after this video is published, all of my videos after that will have some sort of editing in it, whether it's text, whether it's transitions, or whether it's intros. But for now, this is the last non-edited video, and also the last episode of touring our solar system. So the last video we did Neptune. Now we're going to do all of the dwarf planets in our solar system, which includes Pluto, Haumea, Makemake, Eris, and Ceres. So the first thing we're going to be going to is Pluto. So Pluto, once the 9th planet from our solar system, is known for having this gigantic heart in its surface, which most people are referring Pluto to. And it is not the farthest dwarf planet. It's actually the second farthest, being 39 AU from its star. Rotational period is actually tightly locked to its moon named Charon, which is its moon or its binary partnership, because it's literally in a binary relationship. Its atmosphere pressure is so low, but it's actually kind of visible, but it's extremely not really much. Its atmosphere, as we can notice, we only were able to map out one side of Pluto, so that means even in Space Engine there's a section where it's just completely low quality. I have no idea, but so surely one day we're gonna have eventually higher quality photos on the other side of Pluto, since we only have higher quality videos of one side of Pluto, not the high quality pictures of one side of Pluto, and high quality videos of one side of Pluto only, since we send the space probe there. Its other moon is Charon, you may have known, but what you haven't known is that it has 4 other small moons: Styx, Nix, Kerberos, and Hydra. But for now, we're just not going to talk about these. We're going to talk about Charon. So Charon is its binary partnership, or aka its moon, it's taking also 6 days to rotate, an orbital period 6 days, which is the same amount as Pluto, because they're both tightly locked to each other. You may have known that. Pluto's actual tilt is actually kind of a lot. 118 degrees as its actual tilt is a lot, but it's kind of normal considering its binary relationship. It's normal for that to happen. DSI is 8%, diameter 2,374 kilometers, and it is made out of nitrogen in its atmosphere, negative 232 degrees Celsius for its atmosphere, and it's mostly made out of water and ice envelopes. As you can see, it's 37% water or icy, so it's mostly covered in ice. And now here's its dwarf moons. All of them are asteroids. One of them taking 20 days, another one's 43 hours, another one 5 days, another one, which is one of them 20 days, 24 days, 32 days, and 38 days. So this is Pluto, and you may have known this for its 9th planet. Let's go to Haumea. And Haumea is actually kind of weird, so let's tell you why. As you can see, Haumea has a very thin ring system, which makes it for one of very several bodies which are rocky planets having ring systems. And Haumea is actually kind of weird. As you can see, it looks so oval-like. Do you want to know why? Its rotational period's over 4 hours, so it's mostly the centrifugal force that is bulging this dwarf planet so much to the point where it's really just oval shaped at this point. This is what Haumea is known for. Its oval shape. It contains 2 moons, Namaka and Hyaka, which actually are very far from Haumea. One of them is 34 days, and another one is 49 days, but actually kind of close by to Haumea. As you can see, despite being kind of close to Haumea, it still takes 34 days. Its actual tilt is still a lot, 123, and it's negative 230 degrees Celsius, ESI 6%, mass is only 5% of the Earth, diameter is 1,920 kilometers, and it's 43 AU, 282 years to orbit the Sun. Makemake now. So Makemake is also very far away, and also kind of bulging around the equator as well, but its rotational period is still 7 hours, which is a lot. So it's kind of normal for its slightly oval shape. And it has 1 moon. What is it? This. I can't even describe to it what this is, but it is a moon. It has 175 kilometers. That's what I know, because this is such a very long random name. So it's 45 AU from star, 307 years to orbit. Diameter is 1,433 kilometers, and its mass is 4% of the Earth. ESI 6%, and that is Makemake. It's mostly a water icy envelope. Eris, the second largest dwarf planet and the farthest space engine known, being a whopping 67 astronomical units away from Sun, and rotation period is 15 days, and its actual tilt is slightly less, and its gravity is 8% of the Earth. Average temperature is negative 233 degrees Celsius. Mass is 20% of the Earth, and that is Eris, and it has one moon, Dysnomia. Dysnomia is a very dark moon. I have no idea why it's very dark, but what I know is that Dysnomia takes 15 days to orbit Eris, and it's actually a pretty dark object. I have no idea why. It's either space engine mostly. So rotational period is 15 days, entirely locked, just like most of the moons in the solar system. And here's Eris. The last dwarf planet we're talking about is actually the closest dwarf planet, as you can see, and it is Ceres, which is the smallest dwarf planet we know of, being a micro-Terra. It's located within the asteroid belt, and is the largest asteroid of the asteroid belt. It is it is the largest asteroid, but people still refer to it as a dwarf planet for some reason. Rotation period is actually very, very short, just like the other dwarf planets, but its actual tilt is actually very low. Semi-major axis 2.7 AU, and once again it's between Mars and Jupiter, or the asteroid belt. Diameter is 900 kilometers, almost 1,000. ESI is 27%, and its average temperature is negative 122 degrees. So this is the final episode of the Solar System series. I like to give it a proper send-off for this series, and I hope you watch all of the videos in the series in our new playlist. So click here if you want to see the playlist. Anyway, make sure to subscribe. I'll see you in some other series. I'm not referring to this, I'm saying series or playlists, not this planet. So just like everything, I conclude this video. The newer videos will have edits, so bye-bye non-edited videos. And bye-bye to the solar system. So enjoy this interstellar travel, which will last some time. Anyways, adios everyone. You can clock off whenever you like.